So today we're going to use a generic rectangle to factor a quadratic expression. Now two ways you might see a quadratic expression might be the standard form or factored form. Those are two of the most common ways. In the standard form, we write it in order from the highest exponent, variable with exponent, to the lowest. So this one will be from the highest, which is x squared, to the lowest term, which is our constant. When you multiply out your factored form, you should get the standard form. So one way we can multiply this out is by using that generic rectangle. And I can set up each of these factors alongside that rectangle. So this would be 2x plus 1. This would be x plus 4. So we've practiced this before. These multiply out to 2x squared. X times 1 is 1x. 2x times 4 is 8x. And 4 times 1 is 4. Putting it all together, we have our 2x squared term. The 8x and 1x combine to give you plus 9x. And that's going to be plus 4. So we have our standard form here. So the idea between the standard form and the factored form is that there should be exactly the same. You should be able to go from one to the other. So one way you can go from the standard form to the factored form is to set up the rectangle, set up these values on the inside, and then take out some GCFs. So we'll look at how to set up the box later, but once you get it set up, this is what you'll do. You'll look at the first row and see if there's any common factors you can take out of both of these. So I'm going to take out an x. And then we'll use that information to try to figure out the rest of these parts of these factors. So this position here would be x times something to give you 2x squared. So that has to be 2x. Then we can find out the rest of these missing spots. So here, this part of the factor is going to multiply times 2x to give 8x. So that'd be plus 4. And here we have x times something gives me x. Well, that has to be 1. So that tells me what my factors are. I have a factor of 2x plus 1 and x plus 4. You can always double check these by multiplying it out and seeing if they give you the values inside the rectangle. So 2x times x is 2x squared. If you multiply these, we get 8x. X times 1 is x. 4 times 1 is 4. And there it is. That's how we factor. Let's do one more, and then we'll look at how to set it up from scratch. So if you have this set up here, I can actually, let's go to this one here. I can take out an x from both of these terms. Okay. Then I can figure out what would go in the rest of these factors. So to get the negative 5x squared, this would have to be negative 5x times x is negative 5x squared. To get a 10x, I need a negative 2 times negative 5x gives you 10x. And then we can find our last one. So x times what is negative 2x? That's negative 2. So your factors are x minus 2 times negative 5x minus 2. And you can check it. It multiplies out to all these numbers on the inside. So if you look at a bunch of these here that are set up correctly, one thing that you'll notice is that these diagonals, 8x and x, and the other diagonal, 2x squared and 4, they actually will multiply out to be the same values. So 2x squared times 4, that's 8x squared. 8x times x is 8x squared. So their diagonal products are actually equal. They are equal. And this will help us a lot when we're setting up our generic rectangle. So how do we set it up from scratch? So the first thing that we're going to do is figure out what goes into these boxes. Now, from these two factors, when you multiply them out, like say we have our two factors here, the first two terms will multiply to give you this number, which is the same as your leading term. So we'll put 4x squared here. And then when you multiply these last two pieces, this will actually be here and here. You'll get this last term. So it'll be the same as this -3. Okay, so we're going to look at how to set this up. Now the key idea is that these diagonal will multiply to the same as this diagonal. So I'm looking for two numbers that multiply to 4 times -3 is -12x squared. And I want them to add up to this middle number, which is going to be -x, right? So if you combine these together, you should get -x. Okay, so if I think about what numbers would work here, okay, multiplies to -12 and adds up to -1x. Those numbers would be -4x and +1x. +3x. They multiply to -12x, and when you add them together, you get -x. So -4x, +3x, and then from there I can go ahead and factor these out. So take out the x, take out this 4x. Okay, 4x times -1 is -4x. Then multiply this out here. So x times 3. And there you go. There's your factors. 4x plus 3 and x minus 1. All right, let's try one more example on the far end. So here I'm going to put the 8x squared in the first box, the +2 in the second, the bottom right box. And I want my two numbers in this diagonal to multiply to 16x squared. So it multiplies to 16x squared, and when I put these two together, they should add up to my 8x. So what two numbers do that? Well, let's see. Here, 2 and 8 would add up to 10, so that doesn't work. But you could do 4x and 4x. Okay. Then from there, I can go ahead and factor these out. So from the top, I'm going to take out a 4x. This would have to be 2x. Then to get the 4x down here, I'd have to have +2. And 4x times what is 4x? 4x times 1. So you got 4x plus 2 times 2x plus 1. One last one. So this one looks kind of weird, but it's the same kind of principle. I'm going to put the 25x squared here, the -1 on the bottom. And I'm looking for ones that multiply to -25x squared. And they're going to add up to my middle term. Now I have no middle term here, so it's kind of like I have a 0x. Okay, so two numbers that multiply to -25x, but they cancel each other out when you combine them. That would be 5x and -5x. So 5x here, -5x here. Then I can factor out like we did in the other problems. So take out the 5x. What's missing here to make that 25x is 5x again. 5x times -1 gives you this. 5x times +1 gives you this. So all in all, we got 5x minus 1 and 5x plus 1.